these.
Yeah, me too.
And there's two of those.
Two of those. Okay. So, side note that you have. So we are going to test 1 week from tomorrow on 5.3, 5.4, 5.5, and 5.6. Okay. So that is sum and difference of angles, which we will learn second half today. That is double and half angles, which you will learn on your own the next 2 days. That is law of sines, which we dealt with last week. And that is law of cosines, which we dealt with the first half of class today. Okay? So we're teaching on or testing on those 4 sections next week, Wednesday. Okay? So, first off, I would draw myself a picture here of this scenario. And this scenario tells me then that I have angle B is over here. It is 38 degrees. Side B is 21. Side C is 25, which puts this as angle C, and then we'll call that angle A. So, my checklist of things. Yes, I am in an angle side-side case. Yes, I have an acute angle. Yes, my opposite side is shorter than my adjacent side. When opposite side is shorter than the adjacent side, what do we have to do? We got to check the height. So my height is there. So the sine of 38 degrees is equal to h over 25. So then 25 times the sine of 38 degrees is equal to my height. Turn on. 21. Oh, whoa. Tap the brakes. Things going on this calculator, I tell you. It says 25 times the sine of 38 degrees gets me, I get my height here is 15.3915. Agree? Okay, what does that mean? 2 triangles. Okay, so we've got to find the side A, angle A, and angle C in the 2 different triangles. So, triangle number 1, let's hit that one up first. If I go with triangle number 1, that tells me then that the sine of 38 degrees over side B, which is 21, is equal to the sine of angle C all over 25. Doing some math here, that's 21 sines of C equals 25 sine of 38 degrees. That's the sine of C is 25 sines of 38 degrees divided by 21. That tells me then that angle C is the inverse sine of 25 sine of 38 all over 21. Typing that in on my calculator, inverse sine of 5 sine of 38 degrees divided by 21 gets me I get angle C sub 1 as 47.1326 degrees. If that is angle C sub 1, then angle A sub 1 is going to be 180 degrees minus 38 degrees minus 47.1326 degrees. So angle A sub 1 is going to be I get 94.8674 degrees. Then I can utilize the law of sines. Sine of 38 degrees all over 21 is equal to the sine of 94.8674 degrees all over side A sub 1. Put the sub 1s up in here. Fun math. Side A sub 1, sine of 38 degrees equals 21. Sines of 94.8674 degrees. So A sub 1 is that. Divided by that. Let's say, yeah, whoops, excuse me on that one. There we go, there. Now we got it. 21 times the sine of that. We'll call that my answer. Degrees divided by the sine of 38 degrees gets me, I get 33.9866. And now we got a whole another triangle to go. Okay. So now for triangle number 2, angle A sub 2, oops, excuse me, not angle A sub 2, we're finding angle C sub 2 first. Angle C sub 2 is going to be equal to 180 degrees minus angle C sub 1. So 180 minus, way back, my angle C sub 1 was 47.1326 degrees, gives me angle C here as, or angle C sub 2 as 132.867 degrees. Then I can find angle A sub 2. That's going to be 180 degrees minus 38 degrees minus 132.867 degrees. That gives me angle A sub 2 is 9.13262 degrees. Agree with those two. Now, one of the mantras in my life that I like to use is work smarter, not harder. Right? Okay? You just did all this work over here to find side A sub 1. What's the only thing that changes on that work? There's only one thing that changes. Jordan. My angle A. So instead of my angle A being 94.8674 degrees, my angle A now is 9.13262 degrees. You've already done the work. Okay? You can do it again if you want. Okay? But it's right here for you. Side A sub 1 is going to be 21 times the sine now of this angle divided by the sine of 38 degrees. You've already done the work. The only thing that changed was the angle. Okay? Will you have to recalculate it on your calculator? Yeah, but you've done all the work behind it. So I'm going 21 times the sine of my new answer in my degree form, and I want to divide that by the sine, not inverse sine, whoa, Nelly. And I get side A sub 1 here is 5.41389 units. Okay. Yes, sir. Oh, yep, did I put A sub 1? My bad. Oh, now we got it all funky. Hold on, we gotta go. Whoa. We got things going on all over the place. Guys just trying to make one change. Alright, so now we gotta go funky here, funky there, then change the color, then put a 2. All that for a 2. Okay? Good to go on that one? Awesome sauce. We are now switching pages to we are in the yellow packet, page number, or second sheet, really it's page number 3, law of cosines. So this is in your yellow packet now, law of cosines. Okay. You extensively worked with the law of cosines when you were in geometry. So we're not going to go hardcore into developing the law of cosines. We're going to go right into using law of cosines. Sorry, I was running into it. Okay? This work right here at the top of that page is how we derive the law of cosines. Okay? So we plot points in a Cartesian coordinate system, and we, using right triangle trig, find the coordinates of this point B up here. Then we use the distance formula to find the distance of this side right there. And that gives us the law of cosines. Okay? So, in terms of the pattern that is developed, a side squared is equal to the sum of the other two sides, each squared, minus twice the product of the other two sides times the cosine of the opposite angle. Okay? So in reading it, a squared is equal to b squared plus c squared minus 2bc cosine A. Now, if we rotated the lettering one letter counterclockwise, then we'd get B squared equals A squared plus C squared minus 2AC cosine of B. Following the same pattern, if we rotate it one more, we get C squared equals what? A squared plus B squared, you said. The two sides that I don't have yet. Okay. Minus twice those two sides times the cosine of my missing letter. The law of the cosines works in cases where you don't have that complete fraction. So you wouldn't have that complete fraction in the side case or the side angle side case. In all of the other cases, you would still have that complete fraction to allow you to use the law of sines. Okay? So this is at the bottom then of that first page on your yellow sheet. We are going to solve this triangle. Okay? I'm a big fan of drawing myself a little picture to get me through the scenario. This tells me that I've got angle A here as 35 degrees. I've got side B as 15. And side C as 30. I don't have that complete fraction where I have an angle and its opposite side, so I can't use the law of sines. So I have to use the law of cosines. So the three parts that I'm looking for are going to be angle C, side A, and angle B. We have angle A, so I'm going to use the law of cosines that involves angle A, which is A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of A. B squared is 15 squared. C squared is 30 squared. 2 times 15 times 30 times the cosine of my angle, which was 35 degrees. Now, the nice thing about the advent of the modern day calculator is if you are able to see what you can type in, you literally type that in as is. Okay? So you're literally going to type that in as is right on your calculator. Go. When you hit enter, you should get something in the neighborhood of 387.63 ish. But what is that? That's A squared. I want just A. So A is going to be the square root of that. And I get my A value as 19.6917. Oops, that should have been in my other color. My answer color, if you will. A equals 19.6917. The nice thing about the law of cosines is you only have to use it once. Okay? After you use it once, now I have this side A up there. I have angle A, so I can use the law of sines now. So I can say that the sine of angle A, which is 35 degrees, divided by side A, 19.6917, is equal to which angle do you want to go with? Angle B? Okay. So that's going to be the sine of angle B over 15. Fun math, 19.6917 times the sine of angle B is going to be 15 sines of 35 degrees. Sine of B is 15 sines of 35 degrees all over 19.6917. So angle B here is going to be the inverse sine of 15 sines of 35 degrees all over 19.6917. And we go to the old calculator and we get 15 sines of 35 degrees divided by side A and I get angle B here is 25.9074 degrees. One thing left to find, and that is angle C. Angle C is going to be 180 degrees minus 35 degrees minus 25.9074 degrees. I get angle C is 119.093. Okay. Now, one crucial thing that you need to know when you're using either of the two trigonometric laws, law of sines, law of cosines, is that you are always going to want to find the largest angle first when using the law of cosines. Okay? So when you're using the law of cosines, find the biggest angle first. Okay? When you're using the law of sines, you want to find the smallest angle first. Okay? And the reason goes back to when we were dealing with inverse trig functions. The inverse sine is right side of the circle. Okay? Which means the only positive angle that you would have would be in quadrant number 1 when you're using inverse sine. So therefore, when you're using our inverse sine, we've got to get that positive first quadrant angle. That's an acute angle. You can't have two obtuse angles in a triangle. You can only have one. So you find the smallest first when using law of sines, because then it's guaranteed to be in quadrant number 1. Okay. Cosine, inverse cosine, that's top half of the unit circle. So that's wide open. So we take the big one and get the big one out of the way. Because then, after you do the law of cosines one time, you switch over to the law of sines. So since you've eaten up the biggest angle, now you can find the smallest angle using the law of sines. Okay? So that's a definite good hint that you should know when you're doing law of sines, law of cosines. Biggest angle with cosine, smallest angle with law of sines. Okay? So that narrows us down to now the side, side, side case. Okay? When we have, or when we are presented with a side, side, side problem, what we need to do is we need to find 3 angles. Okay? Well, we can algebraically adjust the law of cosines to fit it, or to solve for an angle. So we don't have to do it multiple times. So the very first thing that I would do is I would subtract b squared and c squared from both sides. That's going to give me a squared minus b squared minus c squared equals negative 2 bc cosine of a. Then I would divide both sides by negative 2 bc. That's going to give me a squared minus b squared minus c squared divided by negative 2bc equals the cosine of a. Which is all good. We can utilize that formula if we want for the law of cosines. Okay? Or we could multiply both top and bottom by negative 1, and we could get that the law, or the cosine of a is equal to b squared plus c squared minus a squared all over now positive 2bc. And that is what cosine of a will always be equal to. Then I can use inverse cosine on that fraction to find my angle. Okay? If I follow the same pattern, here I'm solving for a, so I'm going to add the other two sides and subtract off a, and then divide that by twice the other two sides. So what I mean by that is this could be cosine of b. Following the same pattern, I would add together the squares of the other two sides. So that's a squared plus c squared. Subtract off the same side as my angle squared. So that's minus b squared. All over twice the other two sides. which means that the cosine of C, of angle C, is equal to what? What would the cosine of angle C be?
A squared plus B squared minus C squared all over 2 AB.
Agree, Wolfie?
Yeah.
Okay, so that we said was A squared plus B squared minus C squared all over 2 AB. Okay. Okay, let's put that to work. So here is the bottom of that page, that example problem. A is equal to 3, B is equal to 5, and C is equal to 6. Okay? So the very first thing that we just learned was that we need to find the biggest angle. Right? Big angle. So find big angle first. Which one in this particular triangle is the biggest angle? Angle A, angle B, or angle C? Why angle C?
Because that's the longest side.
Exactly. Okay? In a triangle, the biggest angle is opposite the longest side. The smallest angle is opposite the shortest side. So in this case, 6 is the longest side, so angle C is my biggest angle. So on those three formulas that we just wrote down, I'm going to utilize the third one. The cosine of angle C is going to be A squared plus B squared minus C squared all over 2 AB. A squared in this case is 3 squared, that's 9. B squared is 25, so plus 25. C squared is 36 minus 36, all over 2 times A, which is 6, times 5, which is 30. Now we can go to our calculator and we can say that that's what the cosine of C is. So angle C is going to be the inverse cosine of 9 plus 25 is 34, minus 36 is negative 2, divided by 30. Turn it on. Inverse cosine of negative 2 divided by 30 gets me, I get 93.8226 degrees. Do we agree with that?
Yes.
Okay. So that's one of our angles. Now we're done with the law of cosines. So now we're going to go on to the law of sines, utilizing that angle. Which angle do I find next? Angle what? Angle A, because it's the smallest angle and I'm now using the law of sines. So the sine of angle A divided by 3 is going to equal the sine of 93 point, I ran out of room. (93.8226 degrees divided by 6. Six sines of A equals 3 sines of 93.8226 degrees. Sine of A equals this. So angle A is going to be the inverse sine of that. Oh, missed. There we go. So inverse sine of 3 times the sine of C degrees divided by 6. I get angle A here is 29.9264 degrees. Agree? Okay. Then we need angle B. It's going to be 180 degrees minus 93.8226 minus 29.9264. And I get angle B here is 56.251 degrees. Agree? Okay. Supplemental yellow sheet now, the one that you picked up when you walked in to the room today. Okay. I would like you to attempt to draw the picture of this scenario. Remember, on a compass, okay, on a directional compass, it spells out we. Okay, north is up, south is down, and it spells out we. Okay. So if a ship is sailing due east for 60 miles, then it adjusts its angle north, or adjusts its course north 15 degrees. That gets us there. Oops, that's a bad 80. So this side here is 80 miles. We are looking for how far the ship is from port, or its departure point. Do I have an angle in my triangle? What is it? If this angle here is 15, that angle inside my triangle is 165, right? Okay, find me x. I get X is, whoops, wrong color. OCD kicking in. X is 138.827 miles from port. Yes, okay. Now, this concludes the law of the cosines. Okay? You have in your yellow packet, you have multiple extra problems that you can be doing. There's one on this page, and there's 1, 2, 3, 4, 5 on the next page. There are also 2 additional word problems that you can do on today's supplemental sheet. Okay? So if you're still not feeling the most confident in your law of cosines ability, there's multiple ways that you can get better with it, or stop by and see one of us sometime before next Wednesday.
Are these the sheets we're going to turn in for the test?
No.
For like homework?
No. Okay. All right. Okay. We are now going to go on to, so now we're switching back to your own notes. We're off of the yellows now. We're back into your own notes. You will need out your unit circles now for this next portion. Okay. While you're organizing your stuff, let me just inform you of 3 of the classic algebra blunders, the Hall of Fame, if you will, on it. You do not need to write these down. Okay? If I am squaring a sum up here in number 1, lots of people think that that is just u squared plus v squared, but it's not. Okay? It's not. Or if I'm taking the square root of a sum, or of a difference for all of these, let's be honest. Okay? If I'm sum or difference, we could go plus or minus on any one of these. These are all not equal to's. Okay? We think that, or lots of people think that I just take the square root of the first one and subtract or add off the square root of the second one. Okay? Likewise, the same thing if I'm putting it into a function notation. Okay? So my question of the day today is the possibility, or does the possibility exist for that same kind of blunder to happen with sine? Okay? So is this equal to the sine of u plus the sine of v? Well, let's pick one. Okay? Give me a non-unit circle angle. Like, I don't know. That's a unit circle angle. Okay? Let's go 75 degrees. Okay? So the sine here of 75 degrees. Okay? And the other reason I picked 75 degrees instead of 24, I can make 2 unit circle angles out of it. Okay? Okay? So is the sine of 75 degrees equal to the sine of 30 degrees plus the sine of 45 degrees? Well, let's see. Somebody figure out on their calculator what the sine of 75 degrees is.
0.9659.
Okay. What is the sine then of 30 degrees? 1/2, right? What is the sine of 45 degrees? 7071. Okay. If I add those two together, I get 1.2071, correct? Okay. That doesn't work. Okay, because sine has to be less than 1. Okay, so that's not going to fly. Okay, so there's what we call, in the mathematical business, we call that a counter example. Okay? So, however, we have these wonderful formulas for you, and they're already on your unit circle. Okay? These two are number 18. These two are number 19, and these two are number 20. Now, however, they don't look the same on your unit circle as they do written out one at a time here. Okay? So we're going to spend a couple of minutes on reading your unit circle so that you understand. Okay? So here, if I am adding in, oops, I shouldn't underline it because now it looks like plus or minus. Okay? So here, if I am adding, okay, my sign with or my SIGN, my operation, if you will, with cosine, switches, okay, to be a negative. If I'm subtracting, it switches to be an addition sign. Okay? On your unit circle, that looks like cosine of u plus minus v equals cosine of u cosine of v minus plus sine u sine v. Okay? Just know, with all of these formulas, 18, 19, and 20 on your unit circle, if you're adding, that means you're on top of whatever symbol it is. So then you would be subtracting over here because subtraction is on top. Tangent is another good example of it. If we're adding here, that means I'm adding there and subtracting on in the denominator, because that's the top symbol of all of those. Okay? After that, it's just a matter of you using the formula to its fullest, or the formulas to their fullest potential. So, let's go back to the cosine of 75 degrees. Okay? All right? Actually, we did sine before, but we'll do a cosine now. Okay? So the cosine of 75 degrees is not on my unit circle. 75 degrees would be right in about here in the red part of this string on this particular unit circle. Okay? So I can't just get there. So let's come up with, just get shocked. Let's come up with two angles that add to be 75 degrees. What do you got? 30 and 45. And those two are both on my unit circle. So this is the cosine of 30 degrees plus 45 degrees. Okay. Utilizing my number 18 formula, this would become the cosine of 30 degrees times the cosine of 45 degrees plus or minus, which one? Minus the sine of 30 degrees, the sine of 45 degrees. Okay? what is the cosine of 30 degrees? Root 3 over 2. What is the cosine of 45 degrees? Cosine of 45 degrees. Root 2 over 2. At this point in time, we should all be yelling these out because we should have these fairly close to memorized by now. Okay. Sine of 30 degrees. 1/2. Sine of 45 degrees. Root 2 over 2. Mathematically speaking, can I do anything with those two pairs of fractions? Can I multiply them? Refreshing my memory from 4th grade, how do I multiply two fractions? So straight across, right? Okay, top and bottom straight across. So this would become the square root of 6 over 4 minus the square root of 2 over 4. Mathematically speaking, with those two fractions, can I subtract them? Why, Lauren? We already have common denominators. So we could write this as the cosine here of 75 degrees is equal to the square root of 6 minus the square root of 2 all over 4. And that is, if we would go back up here to the instructions, that is the exact value, non-rounded, no decimals, and we used our unit circle to find it. Okay? Now, 75 degrees is a wonderful type of a number. Okay? However, in terms of radians, it is 5 pi over 12 is 75 degrees. Okay, promise. So now, let's find the sine of 5 pi over 12. Actually, before we do that, let me take one step backwards here. Decimal equivalent of this answer. Okay? Because remember, the cosine of, or 75 degrees is right here on the unit circle, right? So the cosine should be fairly close to 0 because cosine is the x value of this particular point. So if I subtract the square root of 2 from the square root of 6 and I divide it by 4, I get something in the neighborhood of 0.25. What did you get, Ben? 0.2588. Okay? All right? Which makes sense. Okay? All right? So now, let's find, or you find, I should say, I've been doing a lot of talking here, you find me the sine of 5 pi over 12. So, give me two numbers that add up to be 5. 2 and 3. Okay, right? So this could be the sine of 2 pi over 12 plus 3 pi over 12. Agree with that? Now, why did we pick two good numbers like 2 and 3? Because what? But what about reducing these fractions? And what do they reduce to? So this is the sine of pi over 6 plus pi over 4, right? Are those two numbers, or those two angles on my unit circle? Yeah. So that works out well for us. Okay. So then the sine, now I'm using number 19. So this would be the sine of pi over 6 times the cosine of pi over 4 plus the cosine of pi over 6 times the sine of pi over 4. Yes, ma'am. Sine? Number 19? Yeah, that one's different. Sine is straight up. Cosine is opposite. But let me throw this question out to you. What if you got all cray-cray, and instead of writing it as 2 pi over 12 plus 3 pi over 12, what if you wrote it as 3 pi over 12 plus 2 pi over 12? Why would you still get the same thing? Because this one would have just flipped around, right? And then flipped here. Yeah, he's pulling stuff. I don't want to know where he's pulling it from, but he's pulling stuff. Okay? Right? In other words, order doesn't matter in multiplication or addition. So we're good.
Wait, was I right? Did I say the right thing?
Yeah.
Really? Let's get...
Okay? Sine pi over 6. Sine of pi over 6. 1/2. Don't leave. Where are you going? I know, but take one of those pink packets right next to you.
Hi, man.
Now you can go. Cosine of pi over 4. Square root 2 over 2. We won't tell them that curling ended this past weekend.
Yeah, actually, no, I thought it was over.
I did too.
I think you just wanted to leave.
I think so. I think so. Don't get any ideas. Okay? Cosine pi over 6 is the square root 3 over 2, and sine is root 2 over 2. Okay? So then this becomes the square root of 2 over 4 plus the square root of 6 over 4. So the sine here of 5 pi over 12 is equal to the square root of 2 plus the square root of 6 all over 4. Which we found earlier should have been 0.95. Yeah, scroll down now. 955 or 9659. Right? Okay. And if I add the square root of 2 to the square root of 6 and divide it by 4, I get 0.96. Okay. Now let's explode some minds. Can we do this exact same problem as a difference? Yeah?
Yes.
Okay. Will we get the exact same answer? If we did it right, we better, right? Okay. All right. What I would like to do, you want to do the sine first or do you want to do the cosine first? Go to cosine back, okay, or go back to cosine. All right. So I want to get this same answer for the cosine of 75 degrees, but now I want to subtract my angles. So, what two unit circle angles subtract to be 75 degrees? Subtract down to be 75 degrees. And they both have to be on the unit circle. 135 and 60. Give me another one. 120 and 45. Give me another one.
76 minus 1.
76 nor 1 is on the unit circle. What about 225 minus 150? Right? Okay. So let's use this first one because they're nice. We'll use that one. Okay. So cosine was again cosine, and then now it's going to be plus sine. So this is going to be the cosine of 135, cosine of 60. Switching signs becomes plus sine 135, sine of 60. Yes? Cosine at 135. Negative root 2 over 2. Cosine at 60. 1/2. Sine at 135. Root 2 over 2. Sine at 60. Negative square root 2 over 4 plus square root 6 over 4. Yes? Are those two the same? Yes, no. Yes? Yeah, they're the same. Because order doesn't matter with addition. So I could easily write the second one as the square root of 6 minus the square plus the negative square root of 2. Okay, which is square root of 6 minus the square root of 2. And then all over 4. Okay? You now, what I want you to do is I want you to find me the sine of 5 pi over 12. This time using a difference. Oops, that should have gone away. Why didn't it go away? Give me a pair. Oh no, yeah.
2 pi over 3 and pi over 4.
2 pi over 3 would be what? That's 8. 8 pi over 12. And pi over 4 is 3 pi over 12. Okay? So that would work out. Okay? What about that one? Does that work? the one that we just did, actually. That's 135 degrees minus 60 degrees. Okay? All right? So, I like this middle one, or the first one. Let's do that one. So, sine 2 pi over 3, so then we're using number 19 here now. So that is going to be the sine of 2 pi over 3 times the cosine of pi over 4 minus the cosine of 2 pi over 3 times the sine of pi over 4. That's going to be the sine at 2 pi over 3 is root 3 over 2. The cosine at pi over 4 is root 2 over 2. Still subtracting. Cosine at 2 pi over 3 is negative 1/2. Sine at pi over 4 is root 2 over 2. So this becomes, I missed. This becomes the square root of 6 over 4 minus negative square root 2 over 4, which is the square root of 6 minus a negative is plus the square root of 2 all over 4, which is shabam, what we found before using the sum. Okay. Provided you do them right, okay, you get to. Don't pack up yet. We got 3 more examples to go. Okay. Yep, you think I'm joking.
No.
Okay. Find me the tangent of 11 pi over 12. I don't care if you use a sum or a difference. Okay? You can pick it. Okay? So going with this one, that is tangent of pi over 4 plus 2 pi over 3. Okay? So tangent at pi over 4 is going, so this is going to be actually, using number 20, this is going to be the tangent of pi over 4 plus the tangent at 2 pi over 3 divided by 1 minus the tangent of pi over 4 times the tangent of 2 pi over 3. Tangent at pi over 4 is 1. Tangent at 2 pi over 3 is negative square root of 3. 1 minus 1 times negative square root of 3. Because you found them already, you don't have to find them again. So on top, we get 1 minus the square root of 3. On the bottom, we get 1 plus the square root of 3 as the tangent of 11 pi over 12. Do not move! I told you that I got stuff to do. Don't even interrupt me by not letting me finish. Okay? So that's that. Now, extremely important. The pink packet that I just handed out to you is due on Friday. There are 3 videos that you have to watch in order to do it. It is due on Friday. Okay? Have a good day. Sorry for keeping you an extra minute.